to put memorize so you'll remember. Okay, we are going to write our general solutions. Okay, and I could add this to a memorization thing if I wanted. Our general solutions are tied to the periods of our sine, cosine, tangent, cotangent. All right, so let's say we've got our periods over here, and I want to show you the relationship between the periods. Then I want you to show you how this is going to be with our solutions here. All right, so sine and cosine have the same period. All right, so they go together. So every time you write a general solution for an equation that has sine in it or an equation that has cosine in it, it's going to look the same. The period for both of these is 2 pi. And if you remember, when we sketched the graphs, we did one period from 0 to 2 pi, and we sketched that. All right, so that was our period. All right, now, our answer, because when you solve an equation for x, like if you remember back to algebra 1, you solved a little equation for x, you got now to x equals 1, or x equals 2, or x equals a half. So we're going to start out with an x equals on every one of them. All right, now, you are going to have a numerical answer, so I'm going to put that in red. And so however many answers you have there, plus, okay, and then we're going to, and I'm going to write it a little bit different than I did in the video, 2 pi, because that's the period, and we're going to multiply it by n, all right, n being integers, multiples of integers, so -1, 0, 1, 2, 3, 4, 5. Okay. That'll never be a decimal because this is integer multiples. Okay. So that's the form, and it doesn't matter whether you write 2n pi or 2 pi n. It doesn't matter. All right, as long as those three things are there. And the 2 pi comes from the fact that the period of sine and cosine is 2 pi. Okay. Now your tangent and cotangent have a period of pi. So their general solutions are going to be x equals, because we're solving an equation. You're going to take whatever answer you get when you solve the equation, because we are going to solve them by hand and with our calculator. All right, and then you're going to add to that integer multiples of the period, which you're going to represent by saying pi n. So that's these two things I made red, so that we would know our answer goes here, and 2 pi is a number, always goes there, 2 and pi always goes there, because that's the period for these two. This is the period for these two. Okay? So if they don't tell you, they don't restrict the interval when you solve the equation, you're going to have general solutions. If they restrict and say they only want in between here and here all the answers, then I could find them. Okay? I'm seeing blank looks. Did that make sense? Okay, let's do a little rough sketch. Okay, so back to our sign from the video that you watched the other day. Okay, here's our generic poorly drawn sine curve. Okay, and then let's say we're solving an equation, and right there we had our red here, we had our red one here. Okay, and then let me find another color here. We had our purple here, and we had our purple here. Okay, very poorly drawn, not to scale. All right. If I restrict what I want to look at, okay, if I restrict what I want to look at, so let's say I only want to look at it from 0 to 2 pi, 0 to 2 pi. I'm going to do curvy bracket. I know I did square here, but I'm just trying to block off the graph. If I look at just a section, no matter what that section is, can't I find two specific answers in that section? See? So if they just say solve the equation and they don't restrict it, then that tells you I need my general solution, because that's going to give me every solution along the curve. All right? If they say solve the equation and they give you an interval, you're going to look inside that interval and just see how many there are inside the interval. So you'll have specific answers. Okay? That's what I was trying to get. Does that make sense? Okay. So better from, does that help? Just what I've said so far, does that help from what you saw in the video 48 hours ago? Okay. All right, so let's do it. Let's solve some. We can do this. All right. Now, in the notes, I'm going to be very specific, and I'm going to like say no restrictions. Okay, they won't do that in your textbook or in Math Excel. All right, so it's going to tell you to solve. And you'll have something like 2 cosine x minus square root of 3 equals 0. All right, that's all you're going to see in on a worksheet. That's all you're going to see in Math Excel, all right, or in the textbook. All right, I'm going to, in our notes, I'm going to go ahead and say that this one is no restrictions. Okay, so in other words, if there's no restrictions, I want to know all the possible answers there are, but I can't numerically list them because there's an infinite number of them. So that's telling me I have to have my answer in the form of a general solution. Okay, so this translates into I need general solutions. Okay, all right, and like I said, they're not going to tell you that. You've just got to know that part of it. All right, now we're going to solve this, and we're going to kind of just like solve it like we do anything. I'm trying to solve for x, right? So can I add square root of 3 to both sides? So then I'd have a 2 cosine x equals square root of 3. All right, trying to get down to where I just have an x. All right, can I divide both sides by 2? Okay, I'm not going to show the algebra step. That just clutters it up. So I'm going to go cosine x equals square root of 3 over 2. Everybody with me there? Okay, so that's just basic algebra. Okay, now do you remember what this is? All right, this is asking you to solve for x. So it's asking for the cosine of what angle equals square root of 3 over 2. So in other words, the other day, I had said, ooh, I'm going backwards to find the angle. So that's the inverse function, right? And yes, Joe is pointing to his unit circle, all right, because that's where we're going to go. Since the square root of 3 over 2 is on our unit circle, then we're going to use our unit circle, okay? I'm going to zoom in just a little bit. You have your unit circle. I tried to make one last period as big as I possibly could so we can see this, okay? So I'm going to put underneath here, or right here, let's put use unit circle. Because square root of 3 over 2, you're going to recognize the numbers. You know that's on your unit circle. All right, now we're going to take a look at our unit circle, and we're going to look at our ordered pairs. Is cosine the first number or the second number? First number. So literally, I'm just going to go all the way around, and I'm going to try to find them. All right, how many are there? Okay, well, ooh, right off the bat, there's one. All right, what angle in radian measures? What angle gives me that? Say what? Pi over 6. In radians, yeah. What angle gives me that? The pi over 6. So I have one answer of x equals pi over 6. Okay, then I'm going to keep looking till I come up with that's a negative one. Don't want that one. There's one right here. I had to go all the way down here. I found another positive square root of 3 over 2. So what angle gives me that answer? 11 pi over 6. Okay, now that's two answers in between 0 and 2 pi. All right, so that's given me, think of it as my red and blue dots from the video. This would be my red dot. This would be my blue dot. So now I need a general solution with this answer in it to give me every red dot. I need a general solution with this answer to give me every blue dot. Okay, so I'm going to go ahead and move this. I'm going to put this up here so that we can remember. All right, what kind of function do I have? I have a cosine, which means it has to be, my general solution has to be in this form. Okay, so I'm going to go general solutions. I am going to have x equals, because that's how I start my formula. X equals whatever my answer is. Well, my first answer is pi over 6. So I'm going to put pi over 6. And then I'm going to do plus. And then every one of them, because this is a cosine equation, I'm going to then add to that a 2 pi n. And like I said, I don't care what order that's in, 2n pi, 2 pi n, doesn't matter. All right, then I have to also do x is equal to my other answer, which is 11 pi over 6. And then again, it's still a cosine graph, so my general solution stays the same. I will finish it off with a 2 pi n. And there's my general solutions. This one, this first general solution gives me all the multiple answers, or all the red dots from the video on the graph from this one. This one gives me all of the multiple answers from this one, which would be all the blue dots. So does that make sense? Was that pretty simple?
Yeah.
And you're going, oh my gosh, I thought this was going to be so hard. And Grace is going, wait a minute, it's still hard. But did you follow me, though?
Yeah, this one makes more sense than the stuff on that Excel.
It always makes more sense, but that's because I'm explaining it as I'm talking and I'm making you think in a certain way. Okay. But yes, I mean, you have to take everything that we're doing and then apply it to because they ask questions different, they phrase them weird. Yeah, I'll give you that. All right, so we think we're good on this one. All right, let's try this again then. Let's do another one with no restrictions, and I may give you a little bit more freedom to try it on your own. All right, let's do 8 tangent x minus 8 equals 0. And then I'm going to go ahead and add the fact that we're going to do this with no restrictions. All right, but keep in mind, Math Excel is not going to tell you that. Textbook's not, a worksheet's not, but...
What will they
Say what?
What will they
Solve.
Oh, so how will they put in, if they have restrictions, then we'll just give a solution?
Yes, and we'll do one of those examples next.
Oh.
Yep. All right, so then this translates into general solutions. Okay, so what I want you to do is see if, don't write the general solutions, just see if you can solve this. Okay, do the algebra first, and then get to the place where you would then use a unit circle. Let's see if you can get that far. And then when you get that far, you gotta put your pencil down so then I'll know when you're done. Some of you have swapped out your pencil for your cell phone, so I take it if your cell phone's in your hand and not your pencil, then that means that you're done. Or at least let's hope that that's what that means. I'm being super flexible. All right, so we added 8 to both sides. So we got 8 tangent x equals 8. Then we divided both sides by 8. And then we got tangent x is equal to 1. And then we know that this is telling us, hey, what angle, when I take the tangent of it, does it give me 1? So then we went to our unit circle. And we definitely went to our unit circles that have the tangent values on there. All right. And we found one of them at pi over 4. And then we found another one at 5 pi over 4. Okay, so we found x equals pi over 4. And we found x equals 5 pi over 4. Say what? And then you just make your general equations. Yep. And so I'm going to put my little cheat sheet up here. Okay, but now this one is a tangent equation. So I'm going to have my answer plus pi n. I'm going to have my other answer plus pi n. So general solutions then, x equals, write the first answer down, pi over 4, And this time, because it's a tangent equation, we're going to write pi n. And then our other answer is going to be 5 pi over 4, and we're going to write pi n. So general solution is pretty simple. But the thing is, do you see how that you couldn't write your general solutions if you didn't have this memorized? That would create a little bit of a problem. And if you want to think of it as a curve, this is going to be the red dot, and this is giving me every red dot on the graph forever and ever in both directions. And then think of this as the blue dot that we saw, and it's giving me every one of the ones, every blue dot on there forever and ever and ever. Okay? All right, now, before we go any farther, let's go back and look. Okay, now, this unit circle is your unit circle, and I added, just last block, some extra numbers on there. Okay, now, we know that this is different than the unit circle you find on the internet because I went ahead and put these values out here, and we know these are our tangent values just because, how do we calculate tangent? Tangent is what over what? Sine over cosine, or y over x. And so it was kind of nasty to do the math of 1/2 over square root of 3 over 2. So then I just went ahead and did all those calculations. Now, your unit circle does not have anything here, 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 or here, because I was kind of thinking that you could just do that in your head, except last block we kind of struggled with that. Okay, so if I did this, and I did y over x, that's 0 over 1. What's 0 divided by 1 is 0. So the tangent value here is 0. All right, and then here, y over x, 1 divided by 0 does not exist, undefined. The calculator gives you an error. We can't divide by 0, right? That's bad. So your tangent value at pi over 2 doesn't exist. What? Oh, that? Oh, that does look like a 1. That my D is not very clear. Yes. That's supposed to be does not exist. Ah, that's supposed to be a D. My handwriting, really bad. Does not exist. I could write out undefined, but now I've just done that in black in my show. I can't erase it now. Okay, all right. Wow, it does look like it. After I looked at that, it did look like a 1. Wow. Okay, 0 divided by that is 0. Okay, again, -1 divided by 0 does not exist or is undefined. All right, and I realize yours is laminated, and you might be able to handwrite it on there. I don't know, but I left those 4 off because I thought you could do those divisions in your head kind of quickly. Okay, all right, so then a little escapade with our undefines. Okay, so let's try one now, and this time let's do one where I place a restriction on it. All right, and if they're going to do that, then you're not going to have general solutions anymore. You will have the specific, every red dot, every blue dot in that interval. So you will have exact answers. Now, we're also going to say, this one I'm going to target as solve by factoring. Okay, because so far, all you have done to solve the 2 equations that we've done so far is just basic little algebra steps. Okay, but you know how to factor to solve an equation. You also know how to use quadratic formula to solve an equation. All right, so those are what we're going to do next. Okay, so let's suppose we had a 4 sine squared x tangent x, and then we had a minus tangent x equals 0. Okay, and let's say we want this solved. Let's put a restriction on here. They won't call it a restriction. I'm calling it a restriction. They'll probably just say, okay, on the half open, half closed interval from 0 to 2 pi. All right, another way that they could write that, they don't have to use interval notation. We all know our interval notation. But they could say 0 is less than or equal to x is less than 2 pi. All right, they could do it like that. Doesn't make any difference. So basically, they're wanting all of our red dots and our blue dots in between 0 and 2 pi. Okay? All right, now, factoring. Do you remember how to factor? You identify all your terms. So there's a term. Terms are separated by plus and minus signs. So this equation has 2 terms. All right, do I have a greatest common factor that I could take out? Tangent x. So we're going to take out that tangent x. All right, and if you remember factoring from the beginning of the year, take tangent x out of this first term, I'm left with 4 sine squared x. Minus sign comes straight down. If I take tangent x and I divide out tangent x, I'm left with a 1. All right, then we've got the zero product principle that says I've got two things multiplying together here to equal 0, so then I just set everything equal to 0, right? So we've got tangent x equals 0. Did I miss something?
I started shaking my foot and then you could start hearing it. I thought it was kind of cool.
Okay. 4 sine squared x minus 1 equals 0. I couldn't hear it up here. So, all right, so this one, super easy, right? Because we're ready for our unit circle. What angle gives us a value of 0? I'm going to write unit circle underneath it so that we know we're looking at our unit circle. I'm going to pull my unit circle back up here. All right, so where is tangent 0? Tangent is 0 at 0. Tangent is also 0 at pi. Okay, so over here I got an answer of 0. I got an answer of pi. Are both of those in my interval from 0 to pi? Yep. Okay, so I got 2 answers so far. Yes?
Why on your restrictions would you do like why wouldn't that also include 2 pi?
Because it's a real complicated explanation for what you know at this point, all right? But they don't want to, when I go to plug things back in, you know how you got to plug it back in, it's got to equal? It's not going to equal, so it's always an open interval here, it's always a closed interval here. I won't say always, 99% of the time. Okay. All right, now, on this one, not as easy as this. I got to do some more work, right? So first thing I'm going to do is add 1 to both sides. So 4 sine squared x equals 1. All right, can I divide both sides by 4? Yes, this is like yesterday. Sine squared x, or 2 days ago. 1/4. Okay, was this in the video? What do I do to both sides? Yeah, do the square root. And when you do the square root to both sides, you got to remember the plus or minus. Yep, so I'm going to actually do that in red and try to show it, because that'll cross out. Plus or minus the square root. All right, and so then I'm going to be down to a sine x. Square root of 1 is 1. Square root of 4 is 2. Okay, so I'm going to have to now use my unit circle. All right, and I've got 2 values I got to check. Okay, unit circle. I'm going to go around that unit circle, and I'm going to look for a positive 1/2 in the second spot, my y coordinates, and then I'm going to go through and look for a negative 1/2. All right, so give me one. What's the first one for a positive 1/2? Oh, some of you go one way around the circle, someone goes the other way. Okay, someone said pi over 6, right? Yep, that's my first one. Okay, so what's the other one? 5 pi over 6. And those are both of my positive 1/2. All right, now go look for the negative 1/2. 7 pi over 6. Okay, and then give me the other one. 11 pi over 6. So these come from the positive 1/2. These come from the negative 1/2. And are all those values in between 0 and 2 pi? Yep, because all the way around the circle, we got them all off the unit circle. So this one, I just found the red and blue dots in between 0 and 2 pi. So if I had a graph of this, I saw the graph, and I marked off 0 and I marked off 2 pi, every one of those numbers would be in there. Okay, and tons of answers. Okay, this one happened to have tons. So 1, 2, 3, 4, 5, 6. There's 6 answers there. So this was a little bit easier probably than yesterday's. Because you used your unit circle, you found them, you weren't messing with the decimals, that sort of thing. Unfortunately, we are going to have to use calculator. We are going to have to mess with some decimals. All right, but again, I think the next example I want to do is I want to do it with the quadratic formula. All right, and we will have to use our calculator to get it because so far these examples, 0 has been on the unit circle, 1/2 has been on the unit circle, square root of 3/2 has been on the unit circle. They're not all going to be on the unit circle, unfortunately. Okay, all right, so I did say I want to throw in quadratic formula on this. So we're going to solve using quadratic formula. I'll go ahead and write the equation out here. So let's suppose we've got like a cosine squared x minus a 4 cosine x plus a 1 equals 0. All right, now before we get into this, let's go back and think about why and how we use quadratic formulas in Algebra 2. Okay, so ax squared plus bx plus c was a quadratic equation. We even did this at the beginning of the year. And if it doesn't factor it, if you can't factor it, you have to use the quadratic formula to solve it, right? Because there's an a coefficient, there's a b coefficient, and there's a c number. And we take a, b, and c and plug it into that quadratic formula, if you remember. You probably memorized the quadratic formula as negative b plus or minus the square root of b squared minus 4ac of 2a. All right, now, I really wish that they would have made you memorize more than just that. Okay, because if I'm trying to solve that equation, I solved that equation for x, right? So I solved it for right here. And to be a quadratic equation, if this is x, then this is always x squared, right? So really, that formula needs to have x equals in front of it because you're solving for x. Doing this gives me my values for x. Okay? Now, this ax squared plus bx, whatever's here is squared, and I have a number, a coefficient, and a coefficient. Now, I'm hoping that you can look at this pattern and see that same pattern here. I have a constant. There's my constant. I have something here in the middle, cosine x, and it's being squared. I had a plain x, and the x was being squared. The negative 4 is the coefficient. What's the coefficient in front of this one? 1. So does everybody see why that's a quadratic equation? Okay, so from there, I know my a equals 1, my b equals negative 4, and my c equals 1. And that's all I need. It's okay that that's cosine x, doesn't matter. All right, but now, I don't want you to do this like you did it in Algebra 2. In Algebra 2, you ignored this and just started cranking this out. All right, now, in this, you can't leave this off. Whatever was right there is right here. But this time I have cosine x. So I have to start with cosine x. I have to have that cosine x there. Okay, is equal to. Now, the right-hand side, I can just plug in the numbers and make it work. All right, negative b, so negative 4 gives me a positive 4, plus or minus square root. If I do negative 4 squared, I get a 16, minus 4 times 1 times 1, all over 2 times 1, which is just going to be a 2. Okay. 16 minus 4 is going to give me a 12 underneath there. I'm going to go ahead and write that. No, I'm not going to write it there. I'm going to do some math over here. All right, this is square root 12, right? Can I simplify that? Do I remember doing this at the beginning of the year? Square root of 4 times square root of 3. So really, square root of 12 is 2 square root of 3. Okay, so I've got cosine x is equal to a 4 plus or minus 2 square root of 3 all over 2. Okay, now can I simplify some more? Can I put a little bubble around this? Can I take this 4 plus or minus 2 square root of 3? Can I factor a 2 out of that top binomial? Okay, if I factor out a 2, I would have a 2 plus or minus square root of 3 all over 2. Because factoring's legal. Can I now cross out those 2's in front? Yeah. Technically, people want to just cross out right here. That's a really bad habit to get into, especially if you forget to do it in all 3 locations. All right, the correct way to do it is to take this binomial on top, factor out a 2, and then you can cross out these 2's. All right, so this expression is equal to 2 plus or minus square root of 3. So then I can simplify a little bit more here. Cosine x is equal to 2 plus or minus square root of 3. All right, now how many answers do I have right here? That's really 2 numbers, right? 2 plus square root of 3, 2 minus square root of 3. But, well, here, and then let's think about this a little bit more. I'm down to cosine x equals some number, right? And so I'm ready to say, okay, what angle, when I take the cosine of it, equals this? But what can you tell me about this number? Is 2 plus or minus square root of 3 on your unit circle? It's not on the unit circle. So unfortunately, you have to use calculator. Okay, now let's talk about this number. What's the square root of 3? It's an irrational number. Square root of 3 goes on forever and ever and ever and ever. All right, so I don't want to round it. I don't want to put this number in my calculator. I want to keep this exact number, all right, and put the whole entire expression in. Okay, so again, I'm trying to go backwards to find the angle that when I take the cosine of that angle, I get this irrational number. All right, so I'm going to write calculator right here. All right, from a few days ago when we did this, we did what? We used the inverse cosine button. All right, and then there is no plus or minus, so I'm going to have to do 2 plus square root of 3 for my one answer. All right, and then for my other answer, I'm going to have to do inverse cosine of 2 minus square root of 3. And make sure you're in radian mode. I don't know which one you did first. Did you do the plus one first? And you're in radian mode. I'm even going to write that down here. Radian mode. Yeah, I got an error. Okay, and so that's okay. This, I'm going to write error. Okay, but basically this just doesn't give me an answer. Because doesn't that happen sometimes? I mean, like, yeah, that happens. Okay, now try this one. Try the second one. Inverse cosine 2 minus square root of 3. And it gave me a decimal that goes on forever and ever and ever and ever and ever, right? So I've got x is approximately equal to a 1.29953. Okay, so I just went out x number of places there. All right, this is my estimate answer. That's my estimate answer that it gave me on the calculator. But isn't this up here my exact answer? So x equals the inverse cosine of a 2 minus the square root of 3 would be my exact answer. Now, technically there's one more step, because there's always one more step. All right, when you did quadratic formula in algebra 2, what were you supposed to do when you got done and found your answers? Plug it back in and see if it worked. Okay, now I can't plug in 1.29953 and see if it works, because it's not going to work. I mean, that's an estimate. I need to plug this back in. I would need to, and the thing is, what you could do is you could, if you're good enough on your calculator, you could do the inverse of this, and get this great big long decimal. The calculator knows the exact number. If you're good with storing values in your calculator, you could store the value in the memory. And then cosine of what is in your memory squared. Minus 4 times the cosine of what's in your memory plus 1. Hit the equal button and see if it equals 0.